And this is the editorial for flowers, which is task Q on the DP contest on AtCoder. I apologize for these birds. Okay, so essentially you have n flowers and they have some height, hi, and some beauty, ai. And each of the heights of the flowers are distinct, and you need to pull out some of the flowers such that the total remaining heights of the flowers or the heights of the flowers are monotonically increasing, and you have to find the total maximum sum of the beauties of these flowers. So let's look at how we would do this. In the first question here, we have 4 flowers, 3, 1, 4, 2, right? And 10, 20, 30, 40. So this here is ai, which is the value of it, and this is h, which is the height. So we want to find the maximum total of the beauties, right? So what is it in this case? In this case, the best thing to do is, if you start with 3, then the next one you could only take would be 4, right? So the total for that would be 40. If you start with 1, though, you could then go to 2, and that would be 60, right? And then your other options, if you start with 4, then that's just 30, and 2, there's 40, right? Again, there's nothing to go to. So in this case, 60 is the best answer, right? We take 1 and then 2. So how can we solve this using DP? It looks like it's similar to it is a longest increasing subsequence, right? Longest monotonically increasing subsequence, but we also have to have the maximum total beauty. So let's look at how the DP would be for this. So we'd have a DP. DP would be using the first I flowers, where the last flower has a height I, which is just hi, right? Then we would want to find the maximum beauty, or it would be total beauty, right? And because each of the heights are distinct, you don't really need to have this beginning part, and it could just be dp of the height, right? So how would you do this? All it would be is a dp for hi, right, would be basically the max of dp of hj, of all j, where j is less than I and hj is less than hi. So essentially what you'd have to do is you'd have to loop through the array, right? You have to go through the array for each flower, you would basically check all of the DPs for the previous flower before it, right? You would just go 0 all the way to I minus 1, right? The heights of those. Sorry, it would be the heights of those. And you would find the maximum. So the runtime of this is n squared, right? You have to loop through all of the flowers, and then for each flower you have to loop through all of the flowers that come before it, and whenever those flowers' heights are less than our current flower we're working with, then we do a max of that, right? And then of course at the end we would add ai, right? Because we are for sure including ai. So how can we optimize this, right? O of n squared is clearly not enough because n is up to 2 times 10 to the power 5. So what can we do? Essentially, all that we're doing is if we calculate it sequentially, right? Where I is 0, 1, 2, 3, blah, blah. All we're doing is doing a max query where the heights are from 0 to hi minus 1. So all we're doing is we're doing a range max query. And in the simplest way of doing this, of course, this is taking O of n, but using some clever data structures, we can reduce this to O of 1. So there's two ways to do this. You can do a seg tree or a binary index tree, or like a Fenwick tree. So essentially what this would look like, the final solution, is you, for I from 0 to n minus 1, what you do is you would update this seg tree or the bit of h of I, where you would query 0 to h height of I minus 1, right? So you'd query, give me the dp for all heights less than h of I, and then you would add the beauty of I, right? AI. And this is especially simple because the heights are distinct, right? So instead of having like a separate DP array or whatever, you could just update it directly into the BIT. And then what you would do, the final answer would just be query of 0 to like the max height. And that's your final solution. So I hope this helps. This is a good like introductory problem into using like range max queries with DP. I hope it helped, and thank you for watching. I'll see you in the next video.